Hello, everyone. I have to ask, can you hear me? Can you hear me now? Hi, everybody. Welcome to the second program of our Winter-Spring 2024 Saturday Speaker Series. I'm Laura Lee Bennett, the Executive Vice President and Programs Chair. Before we go any further, a few announcements for today. First, as you know, March is Women's History Month, a national observance where we celebrate and highlight the women who have made contributions to historical events in contemporary society. You may have noticed in our intro just now that we highlighted some Redmond women who have made a difference in our history and our town. In fact, our speaker today, Lisa Rich, embodies the spirit and force that women can have, both in industry and society. On the theme of Women's History Month, stay tuned for a video interview this Monday, it's coming out, with Mayor Angela Burney. She came to the Society's office last month and we had a chat, and she talked about some of the iconic women that we have had in our town. So there's going to be a short video featuring the Redmond Historical Society and the mayor. So that's pretty cool, yeah. We'll probably be posting, sharing the video on our Facebook page and our website, so stay tuned for that. Second, in anticipation of National Poetry Month in April, today from noon to 4 in our office, we're hosting a free poetry writing activity, and it should be pretty fun. Don't be dismayed by the word poetry. Just about anyone can write a poem. I know, trust me on this. You can stop by. It takes about 30 minutes to answer a series of questions in response to a photo or an artifact in our office. And Holly and the people that will be working in the office afterwards can explain the process to you. But it should be pretty fun. And third, here are two upcoming programs we think you'll enjoy. This coming Wednesday, March 13th at the Redmond Library in the evening from 5:30 to 6:30, there will be a workshop hosted by Humanities Washington speaker Kristen Morales Young. She is also an essayist and a journalist and a wonderful teacher. She's going to be hosting a workshop on how to write a family portrait. It'll be in English for the first hour and then in Spanish for the second hour. And we have flyers in the office that give that kind of information. And if you would like to attend these workshops, you can register through kcls.org. Next, wanted to mention that in April, we're having a speaker program here on April 13th, the history of bicycling in Redmond. It's the Joe Matthews of the Redmond Cycling Club, and our program's committee member, Deb Akerstrom, will be leading that. You get to come up here. And finally, I'd like to read our land acknowledgement. We would like to acknowledge that we are on the ancestral lands of the Coast Salish peoples who continue to steward these lands and waters as they have since time immemorial. We recognize Washington's tribal and indigenous or native organizations which actively create, shape, and contribute to our thriving communities. The Redmond Historical Society is committed to doing our part to engage with and amplify the voices of Native peoples and tribes. And with that, I'm going to turn it over to our president, John Oftebro. Give him a hand.
I would like to start this off as a surprise auction, and I'm going to auction off this Toyota key set that somebody left, and we'll start the bidding at $10,000 for this car. I don't know the year, but if you're looking in your pocket for your keys, you don't need to raise your hand, but they'll be up here before you leave today. Nope. Bob, are those yours? Well, way to go. Is it a hybrid? a gas guzzler. Okay, well, you're forgiven. So, as many of you know, the Historical Society has been around since 1999, and I just figured out that this is our 25th anniversary. So stay tuned for quite a celebration. We're going for something in September at the new Senior and Community Center, and so we'll let you know how that transpires. And we have been collecting Redmond's history for a long time, and we have most of it in place. And a couple years ago, it dawned on me that we haven't done a lot of the recent history, so my articles in the newsletter most recently went through the 4 R's of Redmond, ending up on rockets. So last spring, when I went to Mayor Bernie's State of the City address, City Hall, I was surprised and elated to see this presentation they had naming Redmond as the Redmond Space District. So there were 12 or 13 representatives of the companies in Redmond that are known as the Space District now because more satellites are put in the lower Earth orbit that are built in Redmond than anywhere in the world. And lo and behold, one of the people who was getting their certificate there for that was our speaker, Lisa, who you will meet in just a minute. And it went farther than just a proclamation by the mayor. It also went to Congress. And you know how well, Congress is getting a lot of bills through and a lot of them aren't, but they got a House bill through that gave us the official national proclamation as the Redmond Space District. So you're going to hear more about that. So Lisa was also very generous in supplying information to me for my article, and has supplied a blog post that you can find on our website. So here's some more information on Lisa. Lisa is a successful serial entrepreneur, investor, strategist, and communicator and thought leader who entered the space industry in 2014 to accelerate sustainable, strategy-driven businesses that positively impact the environment, education, national security, and advance the $1 trillion space economy. She's founder and chief operating officer of Xplore, a commercial space services company using its high-capability multi-sensor platform to store and transmit data, achieve data fusion on orbit processing, and edge compute. She's also the founder of Hemisphere Ventures, a top space vector sector VC that has invested in 37 outstanding commercial space companies, including Axiom Space, Umbra, and Lynk. She also has presented at various conferences, engages Fortune 500 think tanks to discuss space strategy and the landscape for space investment with institutional investors and wealth management firms. That's a lot. And she was nominated to the National Space Council User Advisory Group led by Vice President Kamala Harris. She played a pivotal role in establishing the Redmond Space District in Washington State and helped submit for the Congressional Record that I just mentioned. She serves on the leadership board of Space Northwest Alliance, elevating national awareness of space activities taking place in Washington State. Media appearances include Bloomberg and CNBC. And with that, please join me in welcoming our speaker, Lisa Rich.
Hello. It's a pleasure to be here, and thank you for having me. I'm sure you're all wondering what all of that was about that John just shared about my background, because I'm sure it's a mouthful. But I'm going to try and bring it home for you to just maybe take a step back and ask really all of you about your exposure and interest in space to begin with. And I'm going to start with a question of just asking, how many of you have interacted with space today? Okay. And if you haven't raised your hand, how many of you have looked at your cell phone for directions today? A lot of people don't realize that a cell phone is connecting you to space, that blue dot, when you go to Google and you try and find out where you are and where you're going, is not connecting you to a cell phone tower. It's connecting you to satellites that know your location. It's called geolocation. So we have this, entire system that we can't see that's helping us get through our lives. And it's a little bit mind-blowing, to be honest. There's apps on your phone that you can get for free, and I have one on mine that show us what we cannot see, which is the satellites that are flying above our head right this minute. So there's a free app, and I'm using my phone right now to point up, and you can't see it. But right now we have there are about 6,000 satellites that are flying above the Earth, and I wish I could show all of you. You can ask me to see this later. But these are the communication satellites that help us get in-flight Wi-Fi. These are the satellites that are giving us our direct TV, that are giving us our movies when we stream something on cable. It's coming from a satellite, and I can see them all on my phone because they're flying above us right now, just orbiting the Earth. So what's fascinating to me about the space industry is I work so hard on things that we cannot physically see. But there are aspects of this that are the reasons that it drew me to the sector, is what can we do with this information we can collect that we cannot see with the physical eye, and how can we learn more about it? One of the things, if you've seen rocket launches on television, it's very exciting that people come to a rocket launch and they want to see this, the drama of a rocket going into space. But my problem with the media in sharing the rocket launches and all the hoopla around it is, it launched, now what? What did it do? Why did it go up? What was on that rocket that had any importance or utility? We don't share this with the public, and that is why I think we're all effectively in the dark. So I'm here today to share a little bit more about what are those satellites doing that are on top of that rocket. And I'm actually going to give you a little explanation of what happens when that rocket launches, and so you can have a visual as I'm talking. And I'm going to use my water bottle as an example. So a rocket that launches has a fairing at the very top of it, and we're going to pretend that this is at the top of the rocket. So everything underneath the rocket is the propulsion to get it out of Earth's gravity and go into space. But what do we put inside that fairing? Well, right now, as we mentioned, more satellites than any are produced in Redmond, Washington than anywhere in the world. And those satellites are going inside of the fairing, and the majority of them are from SpaceX. So right now, SpaceX inside of the fairing is putting 60 Starlink satellites racked and stacked in the center of the fairing. And every launch has 60 satellites, and they've had a lot of launches. So I looked it up today, and it said that the active SpaceX satellites today are about 5,400. And that's 90% of all satellites flying above our heads right this minute. So my company Xplore is building a satellite as well, so we're a little tiny part of this story. But I just wanted to just map that landscape for you of what's happening in space right now is Starlink satellites. And their goal is to connect us and give us internet with a ground-based dish. And that ground-based dish connects to the satellites overhead, and that can give you internet if it's at your home or if it's on any type of a ground-based platform like a an RV, you could have maybe roaming internet services, for example. But you actually, it's not the full solution to having a satellite anywhere, because you can't be on a canoe, for example, and have your phone and text somebody if it's with a Starlink service. However, you can get internet with another company that I'm an investor in that has effectively converted satellites into cell phone towers. And the satellites are flying above us right now, so that anywhere in the world you can actually get a text. And this is active right now, but again, most of the public doesn't know about it. It's a company called Lynk, L-Y-N-K. So I've been a part of kind of advancing the space industry as an investor and then as an entrepreneur to grow my own company, Xplore, which we'll talk about in a minute. But I'm still kind of setting the ground with you to understand what happens in space and why should we care? Other than, being annoyed that your in-flight Wi-Fi doesn't work the next time you're on a plane. Why is it? Well, we just learned this week that SpaceX is actually putting responders on airplanes so that we have more in-flight Wi-Fi that's better and capable of having consistency and dependability versus the satellites that they connect to today. So back to the fairing. So you have 60 satellites in the center of this, but what you have around it, at the base of it, is a ring. So if you picture a ring around the base of this bottle, and the ring has 5 ports, 5 circles, and those ports each allow us to have a payload, which would be satellites. I'm using the word payload, but a satellite attached to it. So basically, we're along for the ride. It's literally called rideshare. So they're going for the ride, and we're coming along with them. So those 5 different ports allow my company, Xplore, to put its satellite on the rocket and go to space. Very exciting. And we're not the only ones. There was a mission last week that just launched, and 53 companies had satellites that were on that little ring. It's not little. It's actually called an external secondary payload adapter, or an ESPA ring, if you want to learn some technical talk. But 53 companies launched last week with their satellites on SpaceX. And I'm really excited about it because SpaceX is a partner of my company, Xplore, and we will be launching with them this October. So we will have our satellite on that rocket, on their next rocket, which is just thrilling. So why, giving you this basis of information of, how do rockets get to space? I want to say, why do we get them to space? And what are all these companies doing? 53 companies with satellites. I've just shared one so far. That's the company that's converting satellites into cell phone towers that allows you to do internet connectivity. But the biggest market in space today has been that broadband communications to get you your cable services, right? That's what we all know happens in our geolocation with our phone. But the emerging marketplace in space that's happening right now is the remote sensing industry, which technically has been around since the 90s. But remote sensing, and I'll take this notch down for you just because it sounds like, what are we talking about, remote sensing? A camera in space is a remote capability to have imagery that gives us knowledge of what's happening on the Earth. So you might have heard about drones that are flying over land and getting images back, and they're looking at farms, or they're looking at the health of crops. We've had planes flying over the land, getting images and video. But that's a pretty small area that you can cover, and it's very costly to have a drone that can only work for about 2 hours and cover only so much land, or to have a pilot that's going to cost you about $5,000 an hour to try and get images of the Earth. And why would we want these images? Who would want these images? We can get them from space at the lowest possible cost, because if you think about it, space is the ability to fly around the Earth 16 times a day. We can orbit the entire Earth. So if you have a camera that's turned on, that's collecting imagery and is orbiting the entire Earth 16 times a day, now how much imagery can you bring back? Can you watch the Queen's procession, her funeral procession from space? Yes, you can. Can you watch the wildfires that are popping up in our area in Washington State and maybe seeing them or having the vulnerability assessment done to know that a wildfire is about to pop up in a certain area? Yes, you can. Can you have disaster mitigation of, humans that are traveling or on ships that are in the ocean and possibly, the nefarious activities that are going on in our oceans? Can we monitor that from space? We sure can. So if you think about this bird's eye view, more than a bird's eye view, right? Because we're 565 kilometers above the Earth. We can look down at the Earth and say, that farm that was devastated by a flood, how much of those crops are still viable? An insurance company might want to know, what should I reimburse you for? What shouldn't I reimburse you for? What's still healthy? There are a million questions, this unlimited ability to look at the Earth and say, what can I learn from this picture? And then to take a satellite and point it specifically at that information you need at any point in time and derive that knowledge from it is really powerful. So we have a satellite at Xplore that we're designing that has a camera. It has a lot more than a camera, because that was really the first thing that people wanted to do beyond communications for space, is the application of remote sensing using cameras. And my company, Xplore, we said, that's great that you can get imagery. It wasn't high-quality imagery that these companies returned. It was a 2K black and white photograph that's really pretty grainy. So I wonder how many of you saw the Suez Canal when there was a tanker ship that was stuck in the Suez. Anybody see that image? And it was kind of grainy. And it wasn't full color, and it wasn't very informative, but it was the best we had at the time. And good to have it, right? To know what's happening in the Suez Canal. Can you imagine years out from now when we're able to look at a high capability satellite that's not just a camera, but a platform of instruments that allows us to look at video, still imagery, and other types of instrumentation that can not only have an image of what we're looking at, but tell us the chemical properties of what we're looking at. I was just meeting with people in Canada that said, we have pollution in Prince Edward Island area. I want to say Prince Edward Island. And the pollution is coming from the farms. The farms have fertilizer that's running off into the water. And the population of mollusks and mussels is like the canary in the coal mine, that they're the ones having die-off because of pollution from fertilizer from the farms. And they said, can you see that from space? Yes, we can. The fertilizer, the runoff from agricultural lands of different chemicals, we can look at that and know exactly where it's coming from and have a sense of how much is coming onto the water and what direction it's going into and who will be affected by it. So this is just this endless possibilities of what we can do with multiple instruments. I think I've got a slide here. I was trying to get to it.
Here, it auto-played, unfortunately. So,
oh, did we autoplay?
Yeah, speaking of reliability, we managed to reliably have a
connectivity issues.
Yeah.
Okay, all right. So
let me just turn that off. Sorry about that.
We're going to go to that. Yeah, that's what I wanted them to see.
The second one?
Yeah.
Okay. There we go. It should autoplay this time.
So I'm sharing a slide, and We're solving global challenges with Xplore. We're saying, let's have this high-capability satellite that has all kinds of sensors on board, the latest and greatest sensors that we can use to bring data back to answer very difficult questions about our climate, about our land, real estate companies wanting to know how their projects are progressing. They can get elevation data. There's so much data that we can bring back that's important to a lot of different users and commercial users. So what we're about is providing images and insights. And an insight being, how many ships are entering the Panama Canal right now? Can I get that number? I can from our satellite. We can use sensor fusion, which is a next level capability, to take all of these instruments and layer that data together and fuse that data. It's the first ever sensor fusion in the world, so that we don't just have an image of a full color image, and then we have an image that's called a hyperspectral image that's looking at the chemistry of the Earth, or another instrument that's measuring methane or CO2. We merge all of this data together into a file, and then you have multiple layers of it to answer all of these complex questions. And then edge compute. How many of you have heard the term edge compute? Okay, so edge compute is this, again, ability to process the data and ask questions on orbit, in our case.